Hermann Brothers in Port Angeles. So in this presentation, we'll be talking a little bit more about schematic design. Now, before I get into that, in these previous presentations, we have talked about the micronized wood product, and a little bit more into detail than we'll go in this presentation about how we get that and the various constituent materials that go into it. But essentially, just for your information, this is a product that is made from the waste forest residuals, often referred to as slash, that are taken out after being left behind after logging operations, taken from the forest, and then our process would mechanically break those materials down into a feedstock for eventual further chemical refinement on down into what would become a sustainable source of biojet fuel. This, of course, is the NARA, the Northwest Advanced Renewables Alliance, ultimate goal. So I mentioned again in that beginning slide about this presentation being about schematic design. More specifically, again, we're going down to Port Angeles, Washington, and this image right here will be referenced throughout the rest of this presentation. And the last presentation we did involved a lot of products crossing boundaries and what all went onto the site. In this presentation, we will stay within the confines of the site and take stock at all the different processes that will go on there. So key among these processes, obviously, and what will set the stage for the rest of our analysis, is the actual equipment we will use to produce this product. To talk more about that, I'd like to welcome Brent Siegfried up here.
Thank you, Tyler. As Tyler said, I'm going to be taking you through the equipment that goes into our micronized wood process. Now, I'm not going to go as in depth as telling you what each piece of equipment breaks the wood down to. If you want that, you can see it in our previous webinar that goes over the micronized wood process. So let's begin. So our wood biomass is going to be trucked in, so our first necessary component obviously is a truck dump. This truck dump is going to be used to then make a feedstock pile. As we can see here, this is the current Hermann Brothers operations, and I can see our feedstock representing something like this. Now from the feedstock, we will feed it into a greenwood hammer mill. This is where it breaks it down just a little bit more, and then through there we go to our rotary dryer, which brings down the moisture content of our chips. And then again we will have another hammer mill. This one will be dry wood, so it'll have smaller screens and smaller hammers to break up the wood just a little bit more. After this step, it is fed into an air classifier mill, where the fine grinding sort of begins. And then it's fed to a ball mill. Now the ball mill doesn't necessarily break down the particles to any smaller size, but what's really key and happens here is the amorphization. And what that means is it breaks down the cell walls of our wood. So now we're left with a wood flour. It's very fine. You can't store it like a normal chip just on the ground. It would blow away, and also bacteria can grow very easily on such a small surface area. So that's where dry storage comes in, and that would come in the form of a silo. So what's the sizing of this equipment? From left to right is sort of a flow of our equipment. It starts with our woody biomass feedstock and ends with our silo. Each one of these is sort of a visual representation of size comparison of what the equipment will be. Also, to note the power consumption and power of the daily cost, these are very rough estimates, as we use for a lot of the equipment a horsepower conversion into kilowatts and then to kilowatt hours. So it's obviously not that exact. Also, for a pilot plant such as this size, we plan to do 50,000 bone dry tons a year, which translates into approximately 100 bone dry tons of input. And the pilot plant is going to run at approximately 1 truckload an hour, and 1 truckload is equivalent to approximately 28 tons, which translates roughly to about 14 to 15 bone dry tons. We're shooting for that 15 bone dry tons an hour for a 10-hour day to obtain our 50 bone dry tons a year. Now, to talk about more of the criteria and everything we're going to be discussing when going into site analysis, I will hand it off to Victor.
Thanks, Brent. So before we get into the specific analysis of each site, what I'm going to do is sort of describe each item that we address during each analysis, And so to start off, what we have is the item that we're calling reasoning. And what this is it's really just an introduction to each of our 3 sites, including the general reasoning that we have for including it as one of our 3 sites in the first place, as well as current usage of the site. The second item that we're going to be looking at for each of our locations is topography. And the reason why a topographic analysis is important when we're looking at our sites is because we can project any sort of constructability issues or excessive earthwork that might need to take place if our process were to be located there. Next, we're going to be looking at utilities for each of our sites, specifically looking at stormwater treatment facilities, access to the water main, and access to the electric line. And the reason why it's important to look at these is because gaining access to these utilities, if not immediately available, can be a costly expenditure. And then lastly, we're going to be looking at the flow on each of these 3 different sites. And what we mean by flow really is the movement of material in and out of the site. And what we're going to be doing is comparing that to the current flow at the Hermann Brothers logging site and paying specific attention to any sort of points of conflict, which could represent delays or losses of efficiency, which again could cost money. But we're also looking at flow. We're going to look in a little closer, site-specific, to see how equipment could be laid out on that site and how material would flow through that equipment. Now, the common thread between all of these different items that we're going to be looking at is cost. Whether it's difficulty in topography, utilities, or flow, any of these can be overcome, but at some price. So really what we're looking at here is trying to find the site with the smallest initial cost for startup. So I'll get right into site A, which as you can see is up in the northeast part of the Hermann Brothers site. This site was chosen because of ease of access from the road that runs right adjacent, and it's also relatively out of the way of the current mill processes, or Hermann Brothers site processes. At the moment, this location is just used for log storage, so another location would have to be found to replace that loss of space for log storage. Looking at this location topographically, we can see that it's a relatively level space, and we don't project any issues at all with constructability or excessive earthwork in this case. Moving on to utilities, we can see it's located right next to the current water main there on the east side of the property, and it also falls under their current stormwater treatment, so any runoff in this site will go right into their current stormwater ponds. The real issue with this site as far as utilities go is the distance away from the current electric line. If we're going to use this site, we're going to have to get a connection over there from the current electricity that runs over on the west side of the site. Now to look at the overall site flow, the yellow line you see here represents what we project as the process flow of material in and out if we were to use site A, and the red represents current Hermann Brothers flow. That star you see there in the middle is a potential point of conflict between these 2 flows. Again, this is important because it could potentially be costly to have that sort of intersection there. Next, we're going to just move in a little closer and take a look at the process of material specifically on this site going through our machinery. This is a potential machinery layout that we have. As you can see, it makes a bit of a U shape there with our feedstock pile right next to our product silo. Next, I'm going to invite Dane up, and he's going to go through sites B and C.
Thanks, Vic. So I'll be talking about the last 2 sites today. First of those is Site B. It's a little bit different than our other 2 sites where it's located directly in the center of our are directly in the center of your property, and it will pose some unique advantages as well as some unique disadvantages. So the topography of this site, as you can see, is relatively level. It only has a 10-foot drop over the entire site, which we can't imagine would have any negative effect on constructability. Utilities, although they don't appear to be good initially, we actually think that utilities at this site might be better than some of the other sites due to the fact that you already have your debarker and your wood chipper right next to it. So you may be able to use some of your existing infrastructure in order to power and supply this facility. Also, just like the last site, stormwater should prove to be an issue because the stormwater from this site already flows directly into your existing systems. So kind of the big challenge with this site is trying to figure out how flow would work in this site. So we took the approach that we don't want to add new lanes of transportation. We want to use existing lanes and work efficiently with the current Hermann Brothers flow. So as you can see, the silo and the truck dump that we placed on this site, or where we have proposed to place it on this site, are directly adjacent to the current truck dump. And you can also see that there's a couple other conflict points here and kind of down here, and those don't appear to be as major of lanes as traffic, just because they only come as logs are used at that specific point. So here is the proposed flow for the actual site. There's not really a lot that's different in this one from the last one. The only thing that we should note is that we've decided to keep the dry storage and the truck dump very close to each other so that there would only be one place that traffic might be held up. Site C is really different kind of from the other sites just because the land here is not used by Hermann Brothers at all. In fact, it was only recently acquired. So we thought that that's a great opportunity to put a new facility on here. This is the only site that has any kind of unique topography, really, where both the other two are extremely flat and easy to build on. Just right down here at the south end of the site, you can see that there might be a little bit of a challenge with topography, but up at the north end, there should be absolutely no issue with topography. Once again, this site has great access to electricity, just kind of like Site B, and that's something that we really like about this site, and we have been told that electricity shouldn't be an issue here, although water could possibly be an issue here because, as you can see, the water line is a little bit further away from here than either of our other two sites. Another potential issue is stormwater, because the stormwater at this site does not currently flow into your existing systems. So existing systems would have to be likely expanded, not just ditches and such, but also the ponds that you use for this drainage. But really the big advantage to Site C, and the best part about it, is that its flow is completely detached from your current site, and that flow wouldn't be an issue here. And we kind of just show that more, where there's nothing really close. Once you zoom in on the site, there's nothing that you should have to worry about as far as conflicting traffic. We would have to construct a road around your site, or construct a place to move vehicles or turn them around, but I think in reference to everything else, that should be a relatively small problem. So now that I've finished covering the sites, I'm going to pass it off to Tyler Kirshner, and he's going to go a little bit more in depth into comparisons on the sites.
Thanks, Dane. So now that Victor and Dane have went into more detail on each of these three sites, I'm going to show a comparison on each of the three and the pros and cons of each. So this table here represents the reasoning, topography, utilities, and flow things with each site, and the purple represents a disadvantage while the crimson represents an advantage. So starting with site A, it is currently being used for log storage, and so that would be a disadvantage because we'd need to find somewhere else to store those logs. The topography for all three sites will not be an issue, even though Site C has some topography change on the south end. Where we plan on locating our facility would not use that part of the site. As far as utilities go, for Site A, it does have some utilities adjacent, but the electricity would need to be rerouted there across the site, so that could present a challenge. For Site B, The utilities are directly adjacent due to the existing log chipper and debarker, so that shouldn't be an issue. And with Site C, we do have electricity directly adjacent. And even though the water main is not directly adjacent, we know that that property was used as a mill before, so there should be water very close. The only potential issue could be the stormwater, and that is because it is outside of the boundary of the existing property, means that it was just recently purchased for future use. So we may need to adapt to that system or somehow reroute the water into that system or make a new one altogether. For flow, the Site A interferes somewhat with the existing flow, but it's not a major issue, whereas Site B interferes greatly with the existing flow, but that was kind of the purpose of that site, was to just take advantage of the existing flow. But we'll need to look further into that to see if that would, if it could fit all the trucks into it at one time throughout the day. Site C's biggest advantage is its isolated flow. It'd be an isolated facility just located next to the existing facility. So overall, our group feels that Site C has the biggest advantages and the most potential to place our facility. And to wrap up the presentation, I'll invite Tyler to come back up and wrap it up.
Thank you, Tyler. I appreciate that. And like you said, this brings us to the conclusion of this little webinar here today. And again, we look at this picture again, and we see that it is definitely it's definitely focused on the site, but it's seen from a relatively high altitude. And that's the similar kind of approach that we took to this entire analysis. Is we definitely looked at site-specific values, but we can definitely get closer in and focus a lot more on the details of each facet that we analyzed here today. So as with all of our presentations, the feedback that we get from these is absolutely critical to our future success and the directions that we will take coming into this new semester. We look forward to a great 2016 with IDEX, and we hope that you will all be joining us then. Thank you.
As Tyler said, please give us our feedback. Go Cougs, and happy holidays.